And so we've got number 3, recent graduate students' loans total $25,000. If these loans are at 4.2% compounded monthly for 10 years, what is the monthly payment? And if the graduate paid an additional $25 per month, how much sooner would the loan be paid off? And I'm going to add to this, how much interest would that save the student? So with that, we're going to go ahead and get started. So we do have our S value. The initial value of the loan is $25,000. 4.2% is our interest rate, so 0.042. We're looking for the monthly payment. It's 10 years and it's compounded monthly, so 12 for M. So R over M, 0.042 over 12. MT is 12 times 10, so 120. And if I do the 0.042 over 12, let's see what that gets me. 0.0035. So we have S, and we already know what the S is. Schlegel, duh. So we've got 25,000 equals R. 1 minus 1 plus I is 0.0035 to the negative 120 over 0.0035. So on to Wolfram we go. And so we've got 25,000 bucks. We don't know the payment. I is 0.0035. And this is this the wrong formula? That is the wrong formula. Okay. Forget that. We need to come back and grab the right formula. So that one just happened to be in Wolfram when I opened it. So I assumed it was the correct one, and it was not. So there we go. I'm glad I caught it. So again, we've got 25,000 bucks is what was borrowed. .0035. Negative n is negative 120. So we're going to have to do some division. 97, 84, 89. 97, 84, 89. So divided by 97, 84, 89. We get monthly payments of $255.50. And so the monthly payment is $255.50. Next question. We've got, if the graduate paid an additional $25 per month, how much sooner would the loan be paid off? And so what we got to do in this instance is we need a whole new equation. So our Surmton is going to repeat here. And we're still owing 25,000 bucks. And let's get the other information from up here. We know that the monthly payment is going to be $25 more if this person does this. So that will put the payment at $280.50, because we were at $255.50. And our R is going to be 0.042. M is going to be 12. And T we don't know. So how long it's going to take to pay this off, it should be less because we're making more payments. I is R over M and N equals MT. So I'm going to pause briefly and I am going to augment this question because what we should be doing with questions like this is figuring out how much total this person is going to have to pay, and then how much doing this would save them, because that's really what everybody is all about, right? And so I'm going to answer those questions right now. So total payoff is 255.50 times 12 times 10. And so I'm going to do that on my calculator here on the side. We got $30,660. And so in this, how much will this person pay as in interest is the next question that we would be wondering. So this person will pay $5,660 in interest. So total interest is from $25,000 up to $30,660 is a difference of $5,660. So it's going to cost them $5,660 if they go that route. If they do this, we're going to figure out how much of a difference putting in $25 more a month will make. So we've got our stuff set up here. 0.042 over 12 is going to be 0.0035 again. MT is going to be 12 payments per year times the number of years, which we don't know because making additional payments toward the principal of $25 a month should shorten the term of this loan. And so our equation is S equals R times 1 plus 1 minus, or no, what is it, 1 minus? Yep, 1 minus 1 plus I to the negative N over I. And so we're going to have the $25,000 equals R times 1 minus 1 plus 0.0035 to the negative 12t over 0.0035. So let's see how much sooner this person will have their loan paid off. And we're also going to answer the question how much in interest that would save them. So $25,000, we know that the monthly payment now is going to be $280.50. I is 0.0035. N is 12t because we don't know how long. And then 0.0035 again. And what we're going to have is it's going to take 8.92 years. So I don't know why I left the R blank over there. I'm going to fix that. What we should have in here for the R is the 280. I'll squeeze it in there. 280.50. There we go. Not my best work, but it'll be all right. So T is going to be, what is it again? Where did it go? 8.92 years is what we'll call it. So 8.92. And so what this means is that we would be, again, looking for the total payoff and the total interest. So total payoff is going to be 280.50 times 12 payments per year times 8.92 years. And so what we're going to have is 280.50 times 12 payments per year times 8.92 years. It's $30,024.72. $30,024.72. And so if we look at the difference in total payoff, up here we can see that with this option it's 30,660. With this option it's 30,024 and some change. So this person, by doing this, would save I don't know, right around $630 or so in interest. I'll do the math really quick on my calculator just to get the exact number. So we would have 30,660 minus 30,024.72. They would save $635.28 in interest. So this option saves $635.28 in interest, and it shortens the loan by just over a year. And so as I've explained, I'm going to augment this problem to ask those questions that I answered here. So you will see a problem that looks different than this one, and it's going to ask specifically about the total payoff of the student loan, and then what impact adding $25 a month to the payment would have in terms of the total payoff and the amount of interest saved. Again, this person saves about 600 and some bucks, which is not a ton, but it's not chump change either. And it's also nice that they get their student loan paid off a year earlier with having that $280 back in their pocket every month.